Okay. So I guess people can hear me. Maybe somebody can confirm that, because Meet Echo is still a bit a new tool for all of us.
Yeah, at least I can hear you.
Okay.
Hi.
Yeah, thanks a lot. So welcome to the first official virtual TCPM meeting in Meet Echo. So I guess all of us, we still have to get used to the tool. Nonetheless, I hope that we can have a successful meeting. My name is Michael Scharf. I'm one of the chairs of TCPM, and I will present the working group status as the first presentation in this meeting. And then we will just go into the meeting. In the meantime, also please make yourself familiar with Meet Echo. It's the first meeting today, so I guess we all of us have to learn more about the tool, but nonetheless, I hope it works. Together with me, there is Yoshifumi, and I'm not sure if Michael Tixon is also in the call. I don't see him for now, but at least Yoshifumi and me, we are both here, so we have two chairs at least here in the meeting. So Yoshifumi, if you can go to the next slide, please. So this is the usual note well. This is an IETF working group, so the usual note well applies. Please read these notes carefully. There are quite a bit of rules in the IETF regarding, for example, contributions, regarding IPR and other behavior. So please make yourself familiar with those rules of the IETF if you're not already familiar with that. With that, I'd like to move to the next slide with the agenda. First logistics. So we will use Meet Echo. The important new feature is that we will use the Meet Echo queue. So this is different to what we used in the interim meeting. So if you want to queue, please use the icons on the top left of the screen. Second, we will do note-taking by Etherpad or by the new tool. And we do need a note-taker. I have sent out an email yesterday evening, but so far nobody has volunteered, at least as far as I could see. So we cannot proceed without a note-taker. So can please somebody volunteer for note-taking? So we can try to do this as a collaborative effort with everybody contributing there, but we should have at least one main note taker who and it's quite obvious that the meeting cannot start without having sorted out the question, who volunteers as a note taker? Okay, we have a note taker, Neil. Thanks a lot. That is very useful. As I said, I will also in the later talks try to help with note taking. And if all of us contribute, it's easier maybe for note taking, but it's good, important to have one note taker. Then regarding logistics, another important comment, if you speak, first of all, you have to queue typically. Even if we all see your name, nonetheless, please state your name before you speak. This is for people who only listen to the audio, so that they, or to the afterwards recordings, so that it's clear who has commented. So please state your name, even if it's visible in MeetEcho. And as usual, if you contribute to TCPM, please include TCPM in your draft names. And with that, I would move to the agenda for the agenda bashing. So if you can move to the next slide.
So I just would like to mention this meeting has been recorded and there will be published eventually.
Okay. Yeah, sure. Sorry. Yeah, I forgot that. This is the usual agenda bashing. So we have 2 sessions today. Basically, we asked for more time this time than before. This makes sense simply because we got new topics with MPTCP, and we have some related presentations later in this slot. So we have a pretty packed agenda. I ask all presenters also please try to present within the time slot that you've got, so that we can indeed run through all presentations. We will, as usual, start with the working group items. I will start off after this talk with a brief summary of 2140 bis. Then Wes will give a brief update on the 793 bis. Then we have 2 longer talks about REC and HiStart++. And then in the second part of the first slot, a couple of non-working group items, also the ACK rate request and 2 MPTCP-related presentations. In the second slot, the plan is to have 2 talks that are related to the ongoing Yang discussions. The first one is about a working group item in the NetConf working group. The second talk is about what we could possibly do in TCPM. And then we got a late request about TCP test vectors. I've added it formally as if time permits, but we will, of course, try our best to also have some time for the last talk. Is there any feedback, any interest in agenda bashing? If not, I assume that the agenda is okay for the moment. We've approved all requests. So actually everybody who has requested a slot got a slot. So I assume that should be fine. Then I will quickly run through the working group status. So we have 1 RFC that is almost finished. I think it's not officially published as RFC 803, but I guess it will happen within a few days. That's the TCPM converter document. This is almost finished. As I said, I think it will be published within days. We have in IESG evaluation the RTO consider draft that probably needs a new update, but there's been quite a bit of discussion. So it seems most of the comments that are out there seem to be doable, but it requires an update. So that's work in progress. The actual working group documents that are still in progress are shown on the next slide. So we have for quite a bit of the documents presentations in this meeting, so I will not comment a lot on them. We have a presentation on REC. REC has completed the working group last call, but there were a quite large number of comments, and we are at the moment addressing all these comments. So there's been quite a bit of discussion on that, and we will have a talk on that. We also have run a working group last call for the 2140 bis document. There has been a bit of feedback, but not a lot. So that is why I will summarize on behalf of the authors in the next talk the working group feedback that we have received so far. The proposal is to move the document to the IESG. We will also have a presentation on 793 bis. That is out there for a long time already, and it gets very stable. The one of the main open points was the under consideration sections, and Wes will talk about that. Other than that, the document seems very stable, and I'm thinking about a working group last call relatively soon, that is within the next 1 or 2 months. My proposal for this document would be to have a longer working group last call of a duration of 3 or 4 weeks, because it's a complex document to review. So I think it makes sense if we have a little bit more time to review the document. But other than that, at least from my point of view as a shepherd, I believe that that document is ready for working group last call. If there are some comments on that, of course, you could comment on this right now. We have a couple of other documents that were not updated recently. The accurate ECN one was discussed during the interim meeting, but there has been no update in the meantime, and we have no presentation requests. So I guess this probably will have to wait either to an interim meeting or the next official meeting. Same for generalized ECN. We are at the moment discussing in the background with the authors of the EDO document what we can do about that one, but that's still work in progress. And the high star plus plus will also be presented later, so I don't have to comment on that one. We will have also a presentation about the netconf TCP client server, which is formed in the netconf working group. So that will be presented and discussed in the second slot today. So I don't have to comment more on that, I guess. And I think the last slide in the status update is just as a reminder, the milestones that we have. So we are about to finish the REC milestone. So that one is already, I think, in a pretty good shape. The next ones on the milestone list are the 2140 BIS and the RFC 793 BIS. And you've seen that we are either have already done the working group last call or we are planning it. And further out, we have the accurate ECN, the ECN++, and the other documents on our roadmap. So that's the current planning for the milestones. You might have to tune this as usual, but at the moment, that's still the plan in Data Tracker. And with that, I'd like to finish the overview and ask for any feedback or any suggestions, questions, or whatever might have been triggered by this talk. At the moment, I see nobody in the queue, so I take that as a sign that there are no comments, no questions. There might have been somebody in the queue in the meantime, but at the moment, there's nobody in the queue, so that means no comments, no questions, no suggestions. Okay. Anyway, as most of the documents that have been updated have a dedicated slot, so we can discuss them in their corresponding slot. So then I would suggest to move to the next presentation, which I will also give in that case as document shepherd. So this is a short update on 2140 BIS. You will note that I am not one of the authors, so I am giving that talk on behalf of the authors as the document shepherd. So I've already mentioned the status is we had done a working group last call, and at the moment we are about to finishing the comments that we received, and this talk is about the comments that were received during the working group last call. So if you can go to the next slide, please. So this is a brief summary of the history of this document. So there was a bigger editorial update in version 03 with a lot of mostly editorial clarifications and updates. The current version is the version 05, and we've run a working group last call on that version in end of May, beginning of June. And we got a couple of comments during the working group last call. So maybe you can go to the next slide that summarizes the as most of the technical comments that we got. As most of the comments actually were slightly at the end of the working group last call or afterwards. And so there was one comment, or actually two comments about first the security consideration section. The security consideration section has changed in earlier versions, and there was a comment on that one. Albeit I've tried to understand that comment, and it's a bit unclear to me what exactly that comment was about. At the moment, I think without any further information, we just keep the document as it is, as the what was commented is actually in the document. It's just got reworded. But of course, if there are any further explanations for this comment, we would be happy to receive it. I've tried to figure it out on list and off list, but I didn't get any further information on that comment, so there's not much I can further do on that as Shepherd. And second, there was a comment on Appendix C. This is something that was in the document for quite some time already. So this documents a specific algorithm as more or less an example how sharing could be done. That's in the document for quite some time. Nobody has raised any concerns on that before. So the authors, I think, believe that this appendix should stay as it is. Okay, I guess we have a comment now. I think Milja is queued.
Okay, sorry. Now it's on, right? Sorry. Can you hear me?
Yes, we can hear you.
Sorry, somehow my audio wasn't correctly connected. Yeah, I think both of the comments were actually from me about the security considerations and the appendix. So quickly about the security considerations and linkability. The thinking here was that if you use state of different connections or reuse state from a previous connection to a next connection, that could potentially reveal that there's some linkability between the two connections, knowing that both of the connections belong to the same system, even if, for example, the source IP address has changed in the meantime. So that's maybe just like a quick warning you could add to the document.
Yeah, since none of the authors is there, probably the best suggestion would be if you just send this to the list, because as I said, none of the authors is here in the meeting.
Sorry for not replying. I somehow missed that. On the Appendix C, I never kind of apparently reviewed the appendix previously or read the appendix previously, so I never noticed that this was completely included. And it seemed very weird to me that we include like a full another draft into a BIS document, and especially a draft that was like lengthily discussed in the group and was denied. So this is kind of trying to sneak this in there, and it doesn't really make sense to me. I'm okay with like taking a summary or taking a reference to the expired draft because it's relevant, but like having a full copy and paste from that draft that was previously discussed seems a little bit weird to me.
Okay, that one, I explicitly asked also for comments from other people, because I mean, we have, I know that feedback, the authors probably disagree. So actually it would help a lot if others could comment on that specific issue, as whether the Appendix C makes sense in the document or not. So I've explicitly asked for further feedback. It would help a lot if others could comment on that specific question, so that we have more than 2 data points to sort it out. So for the moment, I will leave open the question on what to do with Appendix C. As I said, if you have any opinion on Appendix C, please comment on the list so that we can sort that out. I would definitely look forward to further opinions on whether Appendix C should stay as it is, or if we should, for example, do what Mirja suggested, to summarize it and take out the specific algorithm details. So please comment on that if you have any opinion. And other than that, there was a smaller comment on TFO that will be addressed in the next upcoming release. So if you can move to, I think, the last slide, we will see the text proposal that should address the comment on TFO. So these are the pending changes that should be added to the next version. So the security consideration section at the moment is unchanged as far as I understand. So if you should add something, so please write it to the list. On TFO, the change is the small editorial change that is shown here. And as far as I understand, that working group last call comment would be sorted out by that wording. So we would be fine on that one. And that's all what I am aware of as comments during the working group last call. It's not a lot, to be honest. We have usually more comments during the working group last call. But since it's an informational document, since it's a BIS document, my conclusion as Shepherd is that we will, once we sorted out the comments that are still pending, we will move the document forward. If you have any opinion on that or any suggestion or any other request, now is more or less your latest opportunity to state so. As I said, once we've sorted out Mirja's comments, the plan is to move forward the document so that we can finish that milestone. Okay, and with that, I think I'm done. And the next on the agenda would be Wes.
Hello, can you hear me? Is
Yes,
my audio? No?
Wes, we can hear you.
Oh, okay, you can. Good. All right. Well, hello. I'm Wes, and I have been working on updating RFC 793. I've been editing this document for a few years, and the URL is at the top of the chart. You can look at the latest copy. Revision 17 was posted a couple of weeks ago, and I believe it addresses all the comments and issues that I've heard about to date. The changes in the document have been becoming quite small, as Michael mentioned earlier. The thing that we thought would be reasonable to talk about today very quickly is right on this slide, which is the new TCP header flags registry. This is basically taking the existing TCP header flags registry and actually putting the TCP header flags into it. So if you look at the IANA registry right now, it only contains the 3 ECN-related flags, the ECE, the CWR, and then a reserved flag that used to be the nonce. So the change is, first of all, to make this a sub-registry of the existing TCP parameters registry, which it isn't currently, and then to flesh it out with the other reserved bits, which there's been a lot of discussion about on the mailing list, and I think the consensus was to keep them as reserved bits and simply indicate them in the registry, and then also adding the other TCP control flags to the registry, which are discussed in the document at great length, but not actually defined in the registry. So this table I pulled from the draft, and so what you see is what's in that, and I thought that would make it easy to discuss whether this looks right to people or whether it needs any more work. And since there had been a lot of discussion on this in the past, on the mailing list and in prior meetings, we thought it should make sense just to get a quick acknowledgement that this is what people expected to happen. And that's all I've got, actually. This is my only chart. So the feedback on that is welcome. And following that, I would just say, I agree with Michael said earlier, doing a fairly long working group last call fairly soon. Sounds like a great plan to me. And that's all.
Richard, you should be able to speak.
Thank you. My comment would be, I believe the 12 bits in the flags field are basically standalone, and the top 4 bits 0 to 3, which is the version field of TCP, shouldn't be in that particular field. What would you? So I put it differently. I'm not quite certain I understand the reasoning why we start at bit 4 to 15, when this should be a bit field.
I think I can explain that a little bit. It's so when you look at the way the header is laid out in the sort of 32-bit aligned or maybe 16-bit aligned diagram in the ASCII art, it looks like it's the 4th bit over that is the first reserve bit because of the data offset 4 bits. So
right, but then the header may not need necessarily be the bit in that 12-bit field, but the bit offset from a 16-bit boundary.
Yeah.
Because in my mind, still you have 4-bit field, which is the version, and you have a 12-bit field, which is all the flags, and therefore each individual bit in the flags should be numbered from 0 to 11.
Yeah, you're entirely correct that is an offset from the alignment on the left side of the diagram. I think this was keeping with the existing way that bits are numbered in that registry. We could look at changing it somehow, or maybe saying bit offset instead of bit and explaining what that means. I don't know. I'm open to anything that makes sense.
So making this a little bit more. So I'm not off. I'm fully supportive of having this registry there. But just making it less ambiguous with what the bit column actually means would certainly help.
Okay.
Thank you.
Thank you.
I guess there is a comment from Martin. So Martin, do you want to raise that comment that you've asked in the Jabberstat on the mic, or because I think you mentioned some audio problems?
Martin, I cannot hear you. I think you should check your mic.
Okay, also for the record, also Martin is raising the question, so how will IANA react when we override bits 7 to 9 with the accurate ECN bits? That is an interesting question.
Won't they update the registry as directed in the draft that does that? I don't.
I guess, I mean, the simpler part is that the bit 7, because we would just assign a new name to it. But the interesting question is, of course, what happens with bit 8 and 9, because they have a separate meaning in accurate ECN. So maybe we could record that in the assignment notes. So that would be a way, for example, to explain that those bits have a separate meaning if they're used by accurate ECN. But that is not something we have to sort out for 793 bis. It's more something that we have to sort out in accurate ECN. But of course, we could make good choices here by designing the registry in a way so that it allows further updates. But at least my point of view is the assignment notes could be used as one way to explain bit 8 and 9 in the context of accurate ECN.
Okay, Media, you want to say something?
Yes, and somehow I couldn't join the queue, so I'm now on audio. So we actually don't change the name of bit 8 and 9 because we keep them for negotiation in the handshake as they are, kind of, and then only use this as a field later on. So it's not proposed to change the name. The only thing we will do is assign bit number 7 with a new name.
And if I may,
Richard?
so I believe, again, I fully support that this is nothing that should be going in a 739 bis, but rather in the accurate ECN draft. And I would believe that Jana could still add a secondary reference for when we have this 3-bit field, which kind of overrides after the negotiation the meaning of the base bits.
Yeah, you're right. I guess that's doable. Yes.
So I don't think that this is this needs to hold up the RFC 739 bis.
Yeah, I agree.
I also agree.
Okay. So Richard, you're still queued. Is there any further comment?
Oh, I pressed multiple times, I guess. Sorry.
Okay, so I'm not seeing any further comments on that one. So to me, this implies that we will execute the plan that we've outlined. That is, I will start a working group last call. I will still have to think about the time. Maybe I will wait a bit so that it's not colliding with the summer holiday season. But please expect the working group last call for 793 bis within at least the next 2 months. I will work with the other chairs and the AD and the also when exactly we run the working group last call. But as I said, please expect a working group last call, and please prepare to review the document. So this is one of the most important deliverables that TCPM has worked on in the last years. So we do need reviews to ensure that the document is the best document we can publish. So please comment on this working group last call. Thanks a lot.
Thank you.
And with that, I think we move over to REC.
Cannot hear you.
Eugene, you have to also request audio. Now try again.
Okay.
Yes.
Does that work now?
Yes.
Okay. Sorry about that. Hi everyone. Happy to present the newer update of Rack Draft. Next slide, please. So the main change is that it's really a substantial rewrite, over 90% of the text. After looking at all the comments we received during the last call, Neil and I decided that we really have to significantly change Rack and really focus on the integrating the rack and TLP as a whole, in an integral design to incorporate all of the comments. So there are a few new sections, a new motivation section that clearly explain why we are doing rack and what are the problems we are trying to solve, and a high-level design. So including a very explicit reordering rationale section to avoid people feeling like, okay, we're just taking two wraps, two drafts, and literally just staple them together. And also, a few reviewers suggested it would be good to have an explicit sort of time sequence, kind of like a graph. As examples, we added that into it too. Next slide, please. For the motivation, is really three things we are trying to solve that the current standard three do back heuristic does not do very well. Right? One is that if there is a packet drops in a short flow or toward the end of an application data flight, then three do backs simply don't work that well because you need three do backs. So if it's just one or two, it won't work. The other is the current 3 back heuristic do not detect loss retransmission, and this can be common in a few situations. So one thing we do want to emphasize is that we're trying to be as specific as possible about the scenarios we're trying to fix and avoid any kind of comments that this is a common scenario, this is a prevalent scenario, any kind of this comments about like how frequent this happens, because we understand at different networks, this may not be that common for a particular scenario. The last one is really we trying to tolerate reordering, but for a very only specific type. That is reordering in a very low time degree. So let me give you an example. Let's say you send 100 packets. It's named as P1 all the way to P100, right? And the last one is delivered first, then the rest deliver in order. So in this case, the reordering degree is actually 99. But if you look at the time for this particular reordering, it could be just like the last one is delivered just a fraction earlier than the rest. So in terms of time order, in terms of in the RTT scale, it could be just a very small fraction. So this is the kind of reordering that Rack trying to address. For the other kinds of reordering, Rack won't do as good as just like the 3 back situation, and it's not what the Rack intends to tolerate either. Next slide, please. So for the high-level design, is really the overarching goal is trying to do fast recovery as much as possible. And since it's act trigger, so we're talking about the RTT time scale, and trying to avoid RTO recovery as a last resort. Because one, RTO generally wants to be more conservative. And second, for the standard congestion control, it has a consequence, which is going to reset the ceiling. And in order to achieve fast recovery, is really trying to use the per packet timestamp and use the X to adjust sort of the RTT measurement and the reordering measurement, and simply look at, okay, if a packet has been sent a certain time plus an RTT plus a reordering window, is it less than the current time? Then if that means it has expired and needs to be considered lost. And another sort of small precondition here is that this RTT measurement is not smooth RTT. It is the RTT based on the last packet that was delivered. And we do require this RTT to be measured from the segment that was sent after this S segment. So you know, all right, at least something else sent after this has been delivered. So it's a very strong sign that this packet is likely lost. Now we get a lot of ACK events, but sometimes you do run out of ACK because the segment get lost and you don't have further segments to trigger the ACK. So what do you do? What you do is that after 2 RTT that you send an application data flight, you send one more packet to sort of trigger the ACK. I think the slide needs to move forward. Okay, so that's gradually, so that basically composes of rack, which is use ACK to detect loss, and a TOP is just to send one more packet to probe the loss in case of you suspect all the ACK have been lost, so that this can trigger RTO. And this is the example that we included. That basically you send 4 packets, and the last 3 are dropped, and then you send a TOP. And in this case, since you don't have any new data, then you just resend the last one, which if it's successfully delivered, it will trigger a stack. Now you get a stack, then you get an idea of the RTT, and you know all these packets P0 to P3 was sent more than 3 RTT ago. So you would conclude that this packet must have been lost. So then you retransmit. So remember that in this case with the 3 due back, because you don't get any due back, so you basically will have to do an RTO recovery. And this is the basic idea of how rack and TOP work together. Next, please. So in addition to a lot of this edit and text shuffling, we also add a few this keyword changes. So now we would like the reordering to be should we adapt to based on the DSAC information if eligible, and there should be a reordering timer. And the idea of a reordering timer is that, let's say you know that a packet is not expired yet. Let's say it's 2 milliseconds from being expired. Then the only way that you do mark this packet expired is either through a timer or another ACK event that's happened 2 milliseconds later. So in this case, it's always safer to install a timer so you can do a timely recovery, because otherwise the ACK may come, say, 10 milliseconds later. So you are marking this packet a little bit later than you would like. And there is this a question about, so how is the TLP and the rack dependency? And TLP does require rack, and rack requires SAC. But you can just implement rack. You don't have to implement TLP. It's not recommended, but it will work because you simply just don't send those probe packets. But for the other packet, rack will still do its work. And there is also a clarification about how to manage all these timers. The idea is that all these TLP timer, RTO timer, rack timer, zero window probe timer, they are all timer triggered to send one packet of some sort. So you don't really need to manage and have all these timers. What you do is at any time you maintain one of them, and you can just keep a state variable to point to what kind of timer you want to trigger. Because think of in the case of TLP and rack, any packet is being used to probe the losses, can trigger the loss recovery. So you don't have to necessarily send a tail loss probe packets. You can just send a zero window probe. As long as it's solicited and ACK, then you are good. So you don't need that many timers. And it's actually very, very complex to manage all this together. And one thing we do remove is the ACK delay of 200 milliseconds. A few people do ask, why is it 200 milliseconds? It is from Linux, which we suspect is also from an older version of the BSD implementation. But because of a lot of recent discussions, we know that, okay, this value really needs to be adjusted, so it doesn't make sense to further hard coded that. So we make this implementation specific. So I'm trying to avoid this another magic number, which is likely outdated as well. Next slide, please. Also, we're trying to clarify relationship of the other RFCs, because before the previous draft has this, oh, TLP may work with just SAC only, may not need rack, or rack is just can be implemented as an additional algorithm to do back. So we clear that up. These are all the old text that was left over, never get revised correctly. So TLP rack is an alternative to replace the conservative loss recovery based on SAC. And I believe that's the major implementation by most of the stacks that use SAC. And it can replace the early retransmit. So if you implement rack and TLP, you don't need to implement this too. And for the other rack, sorry, the loss recovery RTOs, TLP are complementary and compatible to, say, limited transmit. Because limited transmit is simply just sending more packets while you getting the first due back and the second due back. And the idea of rack is that the more packet you send, the more ACK events you trigger, and you will just help the loss recovery. So we definitely encourage that. A similar thing goes with FRTO. FRTO is to say, when you time out, if you do have new data to send this new data, because it helps disambiguate if this is a real timeout or not. So that's the same spirit with rack TOP, is sending more packet to probe, sort of double check if something is really lost. And for the RTO star and the RTO restar and RTO, this is simply just computing the timer values, similar to the draft that's becoming the RC, the RTO consideration. It's all the same. These are all compatible. Rack TOP do not manage the value of these timers. And IFL is essentially detecting the spurious retransmission and then actually undo the congestion window. So it works with rack and TLP too, because rack and TLP may have spurious retransmission. It's not always accurate. So in this case, we do encourage, if you find that a loss recovery is spurious, we do want to undo the congestion window reduction. Next slide. I think this is probably the last slide. So that's the end of my talk. We are really thankful to all the people who spend so much time reviewing our drafts, and I know like a rewrite would probably take a lot of time to review again, but I hope it has improved quite a bit. So please do take another look and let us know. Thank you.
Quick question.
Sure.
So I just would like to have a clarification question. So did you modify any logic in rack in the newer version?
Modify what? Sorry, can you?
Logic of the algorithms. I mean, algorithms. The rack's logics, rack's verification. So my question is, the new updates impact the implementation or not?
So we, in the latest version, we did not change the algorithm other than making the the delay act implementation specific. Yeah.
Mm-hmm.
So the rest is more like, you know, the clarification in the text. Yeah.
Okay. Yeah, that's what I want to know. Thank you so much.
Thank you.
Are there any further questions to you, John? If not, I guess we don't have Michael Tixon in the call, who's the shepherd, but I guess the proposal is that once all people who have commented during working group last call have confirmed that their comments are sorted out, we will finish the document and move it to the ISG. I guess that's the plan, as far as I know. So there's quite a bit of ongoing discussion still on the mailing list to get confirmation on that, because it's a significant amount of changes. But as I said, once this is sorted out, we will complete this working group item and ship the document to the ISG.
Sounds good.
Okay, then I guess we are done, and we can move to the talk of Praveen on HiStart++.
Can you hear me? So today I'm going to be talking about HiStart++. So this is a modified slow start algorithm for TCP. Next slide, please. So a quick recap of what HiStart++ is. So the fundamental problem we are trying to solve is that traditional slow start effectively doubles the congestion window every round trip time. In many cases, this can overshoot the ideal send rate for the bottleneck, and that causes massive packet losses. This can cause problems like increased retransmissions because no packets are lost, and then time spent in recovery, particularly for flows that don't exit slow start or are short-lived. This causes a latency increase. And if the packet loss is high enough, this can also result in retransmission timeout, particularly, I think, for implementations that don't have a rack, which can recover from lost retransmits. This becomes a very serious problem for those TCP implementations. So what is HiStart++? It's a very simple modification to the slow start algorithm. It uses the delay increase algorithm from the original HiStart paper, which is linked to in the draft. The particular thing that we do here is that we measure the increase in delay and use that as a signal to exit early from slow start. In some cases, if we get a delay spike, particularly on like Wi-Fi links or due to temporary congestion, this can cause an early exit from slow start very early, and that can cause performance problems as well. So after exiting the traditional slow start, we begin what we call as the limited slow start phase. And we use the congestion window computed by RFC 3742 and also compute the congestion window as it would have been computed by the congestion avoidance algorithm. So for example, if you're using cubic, this would be the cubic congestion avoidance computation of the congestion window. So the max of these two is used until we see a congestion signal. So if we see a congestion signal, then we exit HiStart++. The other contribution of the draft is that we define the tuning constants based on all our measurements and deployment experience. Next slide, please. So this is sort of a English language description of the algorithm in the simplest form. As you can see, it fits on one slide. It's a very simple modification. So on each ACK in the slow start phase, what we do is we update the congestion window as usual. And we also keep track of what is the min RTT. So around here is defined in terms of RTT approximately. You can use the sequence numbers to measure this as the draft formulas show. So for each round, we basically try to remember the last round's minimum RTT. So this is important because we don't want to maintain min RTT for the whole connection because that can go stale. Particularly as other flows enter the bottleneck. So we remember last round's min RTT, which is a very fresh recent value of what the minimum RTT was. And then basically we have some heuristics to determine when to start using delay as a signal. So particularly the congestion window needs to be at least greater than this constant here, low congestion window, which I will explain in the next slide. And also that at least some number of RTT samples have been taken. Again, I'll explain why this is important. So based on this heuristic, then we basically check if the current round's observed minimum RTT is greater than the last round's minimum RTT plus a given threshold, which is also a heuristic. Because this is a delay-based algorithm. If all these conditions match, then we basically exit slow start and we enter the limited slow start phase. We also set the slow start threshold. Then in the limited slow start phase, what we do is for every ACK, as I described earlier, we update the congestion window as the max of what is computed by 3742 and congestion avoidance for the particular congestion control algorithm that's in use. This could be neutrino, this could be cubic, it could be any other congestion control algorithm. And then upon the first congestion signal, which could be ECN, packet loss, etc., we exit high start plus plus, which is what any typical TCP implementation would do. And then the draft also says that this should be used on the very first slow start, and it may be used after idle for restarting the congestion window. We don't currently recommend that this be used for subsequent slow starts because the slow start threshold value has already been determined, and that's usually good enough to be able to not cause the problem we're trying to solve, which is the overshoot of the ideal send rate. Next slide, please. So what changes have been done? So this is now a working group document. The last was an individual contribution, draft 03. So we incorporated review feedback from Mark. Thanks for the review. We also changed the intended status to proposed standard per the feedback from the working group as well as the chairs. So the key changes, we now have a section specifically dedicated to tuning those constants. There were some comments about these values being magic values and what they mean. So we now specifically have text stating what happens when you change these constants. And then we have also a section on deployments and performance evaluations, which have been presented in the last few presentations to the working group. So I'll quickly go over the tuning constants part. So the first one I will talk about is the low congestion window. So we pick the value 16. So this basically prevents the algorithm from kicking in too early. So imagine you started with an initial congestion window of 10 MSS. This at least prevents the algorithm kicking in before we have even measured the last round RTT, as well as very early exit from slow start. So if you can use higher values here, but the higher the value you use, it may cause overshoot on certain networks that are very low BDP. So that's the downside of increasing this value. So but this can be tuned on networks where you have more information. NRTT sample 8. So a TCP implementation is required to take at least one RTT sample every round trip time. But the more RTT samples you take, the more accurate the value is. And particularly for a delay-based algorithm, you need more and more RTT samples. So this is a trade-off here. So lower values will cause lower accuracy in the measured RTT, and the higher values, if you use, they can cause more overhead in terms of computing the RTT. But a TCP implementation may choose to take an RTT sample on every ACK that is valid. So that's sort of the trade-off here of adjusting the value. And then there's the two threshold values. It's basically like a floor and a ceiling for the threshold. Again, a small min here can cause a very early exit from slow start, and the higher max can cause possibly miss any kind of delay spikes if you increase the value too much. So the sensitivity of the algorithm basically is controlled by these parameters. These are again very tunable depending on network conditions, but these values typically tend to work very well in practice. And the last one is the LSS divisor. We specifically state that it should not exceed the value that the RFC said we should not exceed, because otherwise the algorithm becomes too aggressive. If we use lower values, we may be leaving some performance on the table. Next slide, please. So I want to summarize what the status is and the next steps for this draft. Currently, we have 2 implementations of the algorithm as is from the draft. One is in the Windows TCP stack, and the other is in the Cloudflare quick implementation. We also have an implementation in Linux, but that's based on the original high start. I believe it's only based on delay increase, but yes, it does not have the limited slow start component, and maybe the tuning constants may be different. What do we want to do next? We want to look at possibly bandwidth or throughput estimate as a possible signal, if that is easy enough to implement for most TCP implementations. We would like to compare it with just using delay increase. We would also like to do more measurements, more end-to-end measurements on workloads, as well as comparing with BBR startup, which is the other sort of like congestion control algorithm that's being worked on in the ICCRG working group. So that would do for a very good comparison. So that's something that we would like to do in the coming period. For the community, I would say please review, provide feedback on the draft. The more feedback is welcome, as well as if you have implementations, please share performance data. So we would love to get more data from the community, and once we can get more data, I think we can move forward with the draft. So I think that's about it. Any questions?
Hi, Stuart, you should be able to talk.
Okay. Are you guys hearing me?
Yes, we can hear you.
Good. Could you go back to slide 3? So I had a question about the threshold to detect when the round trip delay is growing. If I understand that right, that threshold is a fixed time in milliseconds rather than being relative to the round trip time. And I'm wondering if it makes sense to make it relative, make it a multiplicative factor. And the reason I'm saying that is on a data center network with 10 gigabit Ethernet or higher, where you've got very low round trip times, 100 milliseconds of increase of delay is a hell of a lot of packets being buffered at 10 gigabits. But on other networks like slow DSL or 802.15.4 at a few hundred kilobits per second, some jitter of 100 milliseconds is only a couple of packets in the queue. So I would think on a data center network with very low round trip times and very high throughput, you would want to have a smaller threshold rather than it being just a fixed constant.
Hi, Stuart. Yeah, I agree with the feedback. One of the challenges with a dynamic threshold is computing what that value should be. You suggested an idea of using a multiple of RTT. That is something we should experiment with. Currently, most of our testing has been very much focused on wide area networks and the internet. So, which is where this problem is particularly bad, because if you look at data center networks, the RTT is low enough that even with the overshoot, the time spent in recovery is not that large. So the latency increase is not that bad. Whether this is a algorithm that helps in those cases with a dynamic threshold is something we should experiment and see. So that's something we can certainly get on our plate and measure. This algorithm is very effective, particularly for large latency. So that's where the impact of the overshoot is pretty bad. But great suggestion. I would say that other delay increase algorithms like the LEDBAT have used fixed constants there as well. I think in general, like using dynamic values, I do agree that it makes the algorithm more universal. So thanks for the feedback.
Thank you.
Oh, I'm next. Okay.
Yeah, we can hear you.
Yeah. Thanks, Praveen. So at the last meeting, I think we provided feedback to make this document the proposed standard rather than experimental, and we recognized at the time that 3465 to ABC RFC would need to move up to proposed standard, but I think everyone was comfortable with that. I see now that 3742 is kind of in the same boat, the limited slow start RFC. It's also experimental, and I'm just curious if the group as a whole thinks it is safe to try to BIS that into a proposed standard, or if that is a little more experimental still.
Can you hear me?
Yes, we can hear you, John.
Which one are you asking about, Martin? This is Janai Iyengar. Are you asking about 3742 or are you asking about this one?
So this has two the high start draft has two normative references to experimental RFCs, and I thought we reached something like consensus last time that ABC could move to proposed standard to solve that problem. And I'm curious about 3742 and what the group thinks about that as being mature enough to advance to proposed standard. And if the answer is no, then maybe we need to consider going back to experimental with this draft.
I have to admit that it's Janai Iyengar again. I have to admit that I haven't read the high start plus draft recently, but is there a need for it to have 3742 as a normative reference? This is probably a question for Praveen. Praveen, do you need 3742 as a normative reference for this one?
I mean, yes. I mean, we have a dependence on using that algorithm. I'm guessing that we should be able to subsume the portion that we need here. So in that sense, maybe it doesn't have to be normative. But as it's written right now, it's sort of like references it as normative. But I'm open to changing that.
Yeah, personally, I would like to see this move forward and not be stuck because of the status of other drafts. So if need be, that's what I was thinking. Like subsuming the part of it that is necessary here seems like a reasonable way to move forward.
Thanks, Jana. Yeah, I will look into that.
We could just we could have this draft obsolete 3742 in principle.
So I happen to still have the mic. I don't know why, but I'll ask a question because I wanted to ask this question anyways. Praveen, at this point, how much deployment experience do you have with HighStart++, both on the internet and within data centers? I'm actually quite excited about this algorithm overall, but I want to know what your experience is.
It's default enabled for all connections for about 2 years now. All connections meaning data center, internet, everywhere. So it's in very, very wide use. In terms of data, I think like in the previous two TCPM working group meetings, we presented the data. The draft also has a section where we sort of summarize what has been found so far. But yeah, it's very widely deployed at this point.
And I would finally very much support your work on comparing this against BBR slow start.
Yes, that's on our roadmap.
So Bob, you should be able to talk.
Okay, I'll try. Can you hear me?
Yeah, we can hear you.
I just want to extend on the Stuart's question.
But the audio quality is very
I can't
bad.
hear you. I'm getting audio problems. I'll type my question. If someone else wants to come to the mic, I'll type my questions. This just open to me.
Yeah,
I've got very less
on my end, it's very hard to understand you, Bob.
Maybe I think I can barely hear you, Bob. So maybe you might send a comment on the chat.
So maybe I suggest that Bob should post his comment on the chat. And in the meantime, I think we could let Ian talk.
I wanted to definitely support moving forward with this work, but I also wanted to second Stuart's comment that the fixed thresholds and number of milliseconds gives me some pause and is something I'd probably at least want to make sure we reevaluate before we go forward with it. I'd be very interested in the comparison to BBR's startup. There are some changes there in BBR versus BBR2 that I think are also worth comparing. So I think if you are willing to do that comparison, a three-way comparison would be appropriate. And I'm sure I or Neil or you, Chen, would be happy to chat with you about that. But yeah, thanks for doing this. It's nice to have alternatives in startup that are not quite so aggressive.
Thanks, Ian. Yeah, I think we will probably focus on BBR v2 based on some discussion with Neil. But yes, that's certainly something we'd like to do.
Okay, so we are running over time. I'm not sure if Bob can post his question in the chat window. If not, my proposal would be to take his question to the list and to move on so that we have enough time for the other talks. So I guess anyway, okay. Now we have Bob's question. I read it. It's extending Stuart's question that the threshold is relative. The question is, it's relative to the previous round min RTT, but the upper and lower bounds are constant. So
that is correct. Yeah, Bob, you're right. So the upper and lower thresholds of the problem, they're defined currently hard-coded values in constants in milliseconds.
Okay, then I see Neil is in the queue, and I think I will close the queue after Neil so that we can move forward.
Can you hear my audio?
Yes, we can hear you, Neil.
Okay, great. Yeah, I just wanted to also express support for making the RTT threshold a relative multiple of the min RTT, and also wanted to note that that is the behavior in the Linux code and has been since the original high start in Linux in about 2008. The multiple has changed, and I think right now it's 1/8 or 12.5% of the min RTT, and that has worked well in practice and in production.
Neil, just a clarification. I don't know if you saw if Bob's question, but yes, the draft also has a relative value based on last min RTT, but the upper and lower, the ceiling and the floor constants are currently hard coded in milliseconds, at least the recommended values.
I see. Okay, got it.
Okay, I'd like to close the queue here. So in any case, I mean, this document is fairly new as a working group item, so I assume this will not be the last opportunity to discuss the content. So my proposal is to move the follow-up discussion on the list and have a next discussion then next meeting. Maybe some of the algorithm details need some work. And some other work is needed, but I think that's usual for a working group document. So I'd like to close the discussion on this working group item right now. And with that, I'd also like to close the part of the session that deals with working group items. We have now 3 non-working group items, and we are a little bit behind schedule. So I would like to ask all authors to be a little bit faster than planned, so that we can have all 3 presentations. And the first one to talk is Carl.
Hello, everyone. Can you hear me?
Yes, we can hear you.
Okay. So, hello, my name is Carlos Gomez, and I'm going to present a new draft entitled TCP ACK RAID Request option. My co-author is John Crocroft from the University of Cambridge. Next, please. So the document I'm presenting today is a new draft. However, there's a couple of recent related documents. The first one was a proposal intended to enable a sender with the ability to trigger immediate acts from a receiver. And the second one is a document focusing on a similar area, which, however, focused a bit more on requirements rather than solutions. And in that second document, we included, among other things, the idea of providing the sender with the ability to request some ACK frequency from a receiver. So this second document was presented in the last interim meeting, which was a replacement for IETF107. And after that, there was some discussion on the mailing list, which, by the way, thanks to everyone for the very valuable feedback that we received. And the discussion converged to the idea of defining a new TCP option serving two purposes. The first is providing the sender with the ability of requesting some ACK frequency from the receiver. And the other purpose is allowing a sender to request some immediate ACK from a receiver. So this new document defines such a new TCP option. Next, please. So on the content of the document itself, we start with the motivation by explaining that delayed ACKs is a mechanism intended to reduce protocol overhead, and in many cases, this is actually achieved. However, delayed ACKs may also contribute somehow to suboptimal performance in a number of scenarios. Here we have identified two main categories of such scenarios in terms of the congestion window size. The first one being what we call here large congestion window scenarios, meaning a congestion window size much greater than the MSS. And in these scenarios, saving up to 1 of every 2 ACKs, which is what may be achieved with delayed ACKs, may be insufficient. For example, there may be a goal of mitigating performance limitations due to asymmetric path capacity. For example, when reverse path capacity is significantly limited compared to the forward path one. And another goal may be reducing the computational cost to the sender and receiver, improving performance there, and also reducing the network load by reducing the amount of ACKs. Next, please. So the other main category where delayed ACKs may also contribute to suboptimal performance is what we call here small congestion window scenarios. This means congestion window size in the order of 1 MSS or less than that. So for example, in data centers, the bandwidth delay product may be precisely in the order of 1 MSS or less. So in that case, delayed ACKs will incur a delay which is several orders of magnitude greater than the RTT. Also, in transactional data exchanges, or when the congestion window has been reduced, the ability of eliciting an immediate ACK may avoid idle times or may allow faster congestion window growth, therefore helping to keep low latency and somehow good performance. Next, please. So in this document, we define a new option, which is called TCP ACK rate request, TAR option, with the following associated behavior. Sender may request the receiver to modify the ACK rate of the latter to 1 ACK every R full-sized data segments, where the value of R would be carried in a TAR option field. And also, sender is allowed to request an immediate ACK by setting R to the special value of 0. And then the receiver would be as follows: the receiver complying with this specification and receiving a segment with the TAR option. When the R field of the TAR option is different from 0, according to the current wording in the document, the receiver must modify its ACK rate to 1 ACK per R full-size data segments. And when R is equal to 0, the receiver must send an immediate ACK. By the way, we have a question here for the working group, which is that perhaps instead of the must term that's used here for the receiver, we were wondering whether maybe should, capital letter should, could be appropriate, considering that perhaps in some cases the receiver might not be able to comply with the request from the sender. So perhaps let's move first to the next slide, which is the last one. So this is the format for the TAR option. As you can see, it follows the shared experimental options format defined in RC 6994. So the first field is a kind field, which would take one of the experimental code points, either 253 or 254. The length field would indicate that this is a 5-byte format. Next is a 2-byte experiment identifier, which we are considering to set to 00 AEC as a way to stand for ACK somehow. And the final field would be R, which would carry the binary encoding of the R value. By the way, a comment here is that we, in the long term, we would like to pursue using a 3-byte format. However, we also understand that in the initial stages, the right way to go is using the shared experimental options format in 6994. So, well, next please. That's actually the end of my presentation. So if you have any questions or comments, it will be very much appreciated to hear your feedback. Thank you.
Okay. I am very happy to see this work, and I have another example for your list of scenarios where it's beneficial. In very constrained devices, quite often there is only enough RAM for a single send buffer, and with normal TCP implementations, if you send one segment, then the other end won't ACK it until it gets a second segment, but you don't have enough RAM to send a second segment, and you end up waiting for the delayed ACK timer. And this is often used as an argument why constrained devices can't use TCP. And of course, if you do that, you throw away all the other benefits of TCP. So this would be really useful to remove that objection to using TCP on constrained devices.
Okay, thank you very much for the comment. In fact, we have some minor, actually, we have a reference in the draft on the IoT use case. So perhaps what we may do is update the document to make the point that you made more explicit in the next update of the draft.
I apologize. I'm doing the terrible thing, which we should never do at IETF meetings, commenting on a draft that I have not read. I have not read the draft. I didn't know about it until your presentation. So thank you for the presentation. I learned about something potentially useful for other work that I'm doing. So thank you.
Thank you.
Thank you for the presentation. This is Jana Iyengar. We are working on something quite similar for Quick. I don't know if you have seen that draft. And that's, again, a very early draft at the moment with a lot of back and forth going on with folks who are implementing and interested in it. I'd suggest taking a look at that one as well. In particular, there's one bit that we have in there that I don't know if you've considered, and I'd like to bring it up for you to consider. We have in there a reordering tolerance bit as well. Not a bit. It's there's a debate going on about exactly what it should be, but it's most likely going to be a number. The idea here being that even for TCP, the receiver will acknowledge 1 every hour packets. Excuse me, unless there's a reordering. And if the receiver experiences reordering, it's going to start acting immediately. Now, a sender that knows that the can handle reordering, for instance, could indicate to the receiver that it has a reordering tolerance of n packets or so on. And if the path has reordering, then it also becomes more useful. Now, all of this is in trying to build TCP to be more robust, or the transport to be more robust to reordering in the network. And if you have this option, which is to reduce the ACK frequency, but you are on a path that has reordering, you don't want performance to be suboptimal. So the idea I'm bringing up for your consideration is to think about if that would be meaningful here to do.
Okay, thank you very much for the comment. Actually, I was not aware of the reordering tolerance feature. So yeah, definitely we are going to take a look at that and think about it and take it into consideration properly for the next update of the draft. So yeah, thank you very much for the comment.
Yeah, thank you.
Speaking as chair, I closed the line after Cory, who is the last one to speak.
Hey, can you hear me?
Yes, Cory, we can hear you.
Excellent. Okay. So I plan to read the new rev of the draft. This will be interesting, and I would like to add maybe a little bit more comment on technologies where the transmission of ACKs actually costs, not just in terms of bandwidth, but in terms of transmission. But so that's an offer of some comments. My question, though, is a little bit similar to Jana's. You mentioned that there was an option, an ability to turn off ACK delay as if it was off for an RTT. But maybe there are cases where you might want to turn it off for a few packets, maybe to do some sort of probing, rather than just ACK every segment for a period of time. So maybe there's a possibility of some more nuanced way of getting lots of ACKs. Have you thought about how you might ask the receiver to send ACKs maybe for the next few segments rather than turn them on for an RTT?
Hello, thank you for the comment. Well, actually, we hadn't thought about it, but yes, I agree that this may be an interesting feature. So yes, we are also going to take this comment into consideration for the next update of the draft. So yeah, thank you.
Okay, look forward to that. Thank you. Bye.
Thank you very much.
Okay, since we are short on time, I think we have to move on to the next talk. We have now actually 2 talks that are related to MPTCP. My proposal is that we have the first one now, and we will postpone the second one into the second slot before the if time permits one, because I'm not sure if we can have both of them, but we still have some time left in the second slot. So my proposal is we now only discuss the first one. That's the one related to multipath robust session establishment. As I said, the second one will be rescheduled to the second slot. And with that, I'd hand over to Markus, I guess. And Markus, we cannot hear you if you're speaking.
Can you hear me now?
Yes, now we can hear you.
I entered also the queue. Yeah, okay. So probably then you can also see me on video. Yeah, okay, very good. So yeah, I'm happy to present multipath TCP robust session establishment. So the first time we entered Tcpm for that. It's a joint contribution from Jiao and myself. Jiao is also part of this call, so she is available later on for comments and questions. So next slide, please. Yeah, so even if it appears here as a 0.0 version, the document has some history from the multipath TCP working group, which is closed. So we entered now Tcpm. It's about an extension to regular multipath TCP, standardized in RFC 6824, and also to the newer multipath TCP version in RFC 8684. It is designed to provide a more robust establishment of multipath TCP sessions. We come to this in the next slide, what it means. In the draft itself, we describe 4 approaches. It's Roby Timer, Roby Sim, Roby eSIM, and Roby IPS. Roby stands for Robust Establishment. We also describe combinations of those approaches. So if you look into, you will find out. So to the next slide, please. Okay, so a short solution recap. So with regular MPTCP, we have some limitations regarding the multipath TCP session setup. So if the initial flow over the initial selected path cannot be established, there is no connectivity, even if there are other working paths available. So that's why we have Roby Timer, SIM, and IPS. So in short, Roby Timer uses the SIM retransmission timer to try subsequent paths if the initially selected path fails. Roby SIM uses all available paths simultaneously to establish the multipath TCP session, and Roby IPS tries to derive path qualities from measurements and select according to these measurements then the most promising path. Next slide, please. So which changes we have made since IETF106? So originally for 107, we planned to have a hackathon participation. Unfortunately, due to Corona, it did not happen. So that's why we focused this time on the demonstration of an own implementation we did before this meeting. So we have some material in the slide set available. And also we have some videos uploaded, also mentioned here in this presentation later on. We also have submitted now the 0.0 version to Tcpm. Next slide, please. Okay, so that is the demo environment where we focus today on, and where I present some results. So I think it's pretty obvious. On the left side, we have two handsets, two mobile phones, one with the regular multi-pass TCP and one with our Roby implementation. So either the timer, SIM, or IPS. And both mobile phones are connected to cellular and a Wi-Fi connectivity. We terminate the multi-pass TCP in a cloud instance with a multi-pass TCP proxy so that we can access internet services. In this demo or in this testbed, we accessed the DoYu application. So next slide, please. Okay, so the initial path selection is very important for the multipass TCP. So we assume for a regular multipass TCP implementation that in a mobile handset, the default path is set to Wi-Fi. So it will always try to open a multipass TCP session over the Wi-Fi access. For the Roby timer implementation, we assume the same. So the default path is Wi-Fi. For the Roby IPS, so the initial path selection, it is dependent on measurement, which path is used to establish a multipass TCP session. So in all of these solutions, Roby timer and Roby IPS, whenever the decision was or is made which path to follow, then the traditional multipass TCP session establishment will execute it. For Roby SIM, that is a little bit different. Here we change the process of session establishment. Here we use all paths or all accesses which are available to establish a multipass TCP session. That also implies protocol changes. We think they are well described in the draft document already.
This is Michael speaking. As you have about 5 minutes left at most, so I suggest maybe you can go faster.
Yeah. Okay. Okay.
I mean, we can read the slides ourselves. It's probably more important to have a discussion on the next.
Okay. Okay. Yeah.
We can read the slides. Move on.
Yeah. Okay. Thanks, Michael. Yeah. Then please next slide. Okay, so for the testbed results, we measured the time to access the DoYu app and get the content. And we had two test scenarios where the Wi-Fi signal was weak compared to the cellular connectivity. Next slide, please. Okay, the videos to this test you can find on GitHub. The link is in the slide. So we compared Roby timer, Roby SIM, Roby IPS with a regular multipass TCP when the Wi-Fi signal is bad in terms of dBm. Next slide, please. And you can see that for the regular multipass TCP, it took 8 seconds to get the content in the DoYu app. And for all the Roby solutions, it was much faster. It was around 5 seconds. Next slide, please. Okay, here the scenario was a little bit different. Also, the Wi-Fi signal was weak compared to the cellular, but here in terms of bandwidth. And again, we compared all Roby solutions to the regular multipass TCP. Next slide, please. And again, here you can see that for the regular multipass TCP, we had a much longer much higher time to get access to the content, whereas for all the Roby solutions, it was much faster, and roughly we had a gain around 40 to 50% for each of the Roby solutions. So next slide, please. Okay, coming to the conclusion. So we have now different implementations available, one at Huawei, one at DT. The DT one is outdated, whereas the Huawei one is based on the multipass TCP implementation available at multipass TCP.org. We have now a successful independent validation of Roby. So with the old DT implementation, I think 3 or 4 years old, and the newer one from Huawei now. So in the next steps, we plan to enhance the measurement setup for a better comparison of the testbed results, and maybe also to add more scenarios. And also we plan to integrate the Roby eSIM. That is a special enhancement to the Roby SIM implementation. So the main question I have today is it from your view ready for adoption? And in general, we are very happy to get some feedback from you now.
So this is Michael speaking, speaking as chair in this case. For the record, also to this working group, because it's a document that's new, I think there are IPR disclosures related to this document, correct?
Yes.
And when I check, there are at least two IPR disclosures. So when I checked it last time, they didn't explain the licensing conditions.
Right.
And I mean, it's maybe my own personal view, but you can hardly expect to run a working group adoption call if you're not explaining the licensing conditions. I mean, there's an IPR disclosure, that's fine, but I guess it would be fair to the working group that the companies that have IPR explain under which conditions they are willing to let others use the IPR. I mean, this is a legal step. It's maybe not a formal precondition, but I think at least in TCPM, where we hardly deal with IPR, it's something reasonable to ask for, so that the companies declare the licensing conditions.
Michael, I think that's fair, and we can focus on that. Do you think that is the only hurdle to get adopted?
I mean, I'm still speaking as chair, so I'm more looking at the formal things. At the end of the day in TCPM, the implementer's interest matters a lot, but of course the IPR can influence a lot the interest of others or not. So that's why I think it's something you should probably look at least.
Okay, are there further comments which might prevent adoption?
Yes, here's Mirja Kulevent. I don't see, unfortunately, any of the MPTCP authors in this meeting, but I roughly remember that we had in some previous MPTCP sessions we had some discussion about the security impact of having two sessions or two requests open or try to open two paths at the same time. So I think there was some negative implication on that, because that was not one of the assumptions when the protocol was designed. But I would need to go back and look into the minutes of that meeting to actually figure out what the problem was. I'm not sure if you remember.
Yeah, for sure. I remember, and I think we have well described that there is no security implication from our solutions. We have very different solutions. So with the Roby Timer, the Roby SIM, the Roby IPS, they are very different in respect to security. And yeah, again, I think that is well described in the document. So yeah, my question is how we deal with that.
Yeah, I can check the document, but so what I remember was that only the case where you try to really use two passes at the same time was the problem, where maybe an attacker could kind of try to block one of them and then use the other one or something. So that was a special case.